Hi, everyone. My name's Johnny Press. I am the Chief Technology Officer of, I was about to say the wrong name there, Data Intellect. Sorry, this has put me completely off because that's not the slide that I had. But anyway, right, let's just crack on. Somebody obviously has, okay, great. So I'd like to start just by saying thanks very much for KX for having us here. We're partnered up with KX. We're excited. We're looking forward to the future together. So that's great. And obviously, it's nice to be here, right? So who am I? So I've been in this community. I'm a KDB Plus developer for 19 years. So there's a lot of people here who I know who've worked with over the years and spoken to in Listbox and all those sorts of things, which is so it's great to see everybody again. I'm slightly unusual though for somebody of my vintage because unlike a lot of people who've been doing it that long, I never learned K. So I used to work for First Derivatives for 9 years. I worked for KX for a bit, and then I joined AquaQ, who then became Data Intellect. And my first day of First Derivatives, Brian Conlon told me, Q's the new thing, you're learning that, you're not learning K. And if anybody ever knew Brian, if Brian told you you weren't doing something, you were not going to do it. So I have never learned K. So who are we? Okay, so we're Data Intellect. We used to be called AquaQ Analytics. So what I want to do today, I want to do a couple of things. I want to tell you a little bit about ourselves, what we do for people who don't know us. And then we're going to kind of walk through some problems that we've seen in the past and how we've addressed them and kind of go from there. So that's kind of the format. So, and again, as in our previous guys at AquaQ, we've been around for almost 12 years. We've rebranded to Data Intellect. So, the driver behind the rebranding exercise is a couple of things. So, it gives us a new, fresh look. It helps us attract talent, right, which is great. But also it allows us to reshape a little bit our offering, right? So, because we don't just do KDB, and I think that's important for us to get across here. It's a large chunk of our business, but it's not the be-all and end-all. So what is it we do? So we have 4 separate service streams essentially, and we'll come on a little more detail to the KDB and time series engineering piece. So Gary Davies over here, he runs our time series KDB bit. So I'll talk a bit more about Gary later. What else do we do? So the other piece that we do, so our performance software engineering. So what our service offering is, essentially we're a services company. We're about 250 people. We've got a lot of experience in financial markets, capital markets. That's where we do most of our work, most of our development. We have a team of C++ and Java engineers who focus on kind of the low latency, the other parts of the low latency environment that KDB tends to fit in. So feed handlers, matching algos, stuff like that. We also have a data engineering group. So again, it sort of sits a bit parallel to the KDB group. Their Python is their tool of choice. A lot of the things that Alex was touching on, data pipelining, data engineering, analytics, visualization, anomaly detection, data cleansing, all that kind of thing. These guys all help us with all that. So we're kind of doing the things we do in KDB, slightly different technology. And then we've got our service delivery piece, and that sort of sits around everything and sort of makes sure that we actually do what the clients want us to do, because that's the most important thing in the world. And just before I flick on, I'd like to make sure everybody's looking at the slides so they can see the best part of our rebranding, which is that slide transition. To be honest, let's just go. There we go. Look at that. Thank you. That was nothing to do with me. Right, so time series engineering, right? So let's talk a bit about this, because that's why we're all here. This is what we do. So what do we do in this group? So we do a number of different things. We've got a global team. We've got people all around the world. Probably, so we're a company of 250 people. About 70% of the business is in the KDB space, so a large number of people. In KDB land, we have advisory services, so we'll come in, look at system architectures, give you advice, tell you how you can improve things, all that kind of thing. We provide development resources, so that could be individual people, but hopefully teams of people. They can drop into your own projects, or we can take on a whole project itself. So you define a deliverable, we'll go and build it, bring it back, show you how it works. Hopefully it works, and you pay us. We also run managed services and support. So we have for 3 large institutions, we run 24 by 6.5 support services. So we've taken on the whole thing for 3 large places. It runs a round-the-clock model, follow the sun, all the good stuff. We also do training. So we've got an online training portal. So if anybody here is new to KDB and wants to learn a bit, come and talk to us. So people like that because it allows them to do them their own time. So we've got a couple of courses. One of them focuses on developers. Another one focuses on quants. So it's slightly different use cases. I think we've sort of seen querying the data opposed to building systems. We do in-person training as well. And we also do bespoke weird stuff sometimes. So one of the things we're doing at the moment, one of the places we work with wants to find people within the organization who want to learn KDB+. So we've put together a 6-week program that allows them to self-learn, and then we're putting a hackathon together at the end of it, which will go and run for them in Portugal, which is nice, so even better for us. And the winner gets a KDB job, which is lovely for them. But fundamentally, we'll do work for cash. So, right. So, what are we going to talk about here today? So, I want to talk a bit about our advisory piece, right? So again, we see systems, we see a lot of systems, and we go in and we tell people, how they work, how they could work better, all that kind of stuff. But fundamentally, right, a lot of systems sort of fall into this pattern here. So, you've got 2 parts to it, essentially. You can logically separate into 2 parts. So there's the real-time analytics piece, so the super latency sensitive stuff that is where all the magic happens. And then you've got the storage component. So the bit that saves down the data at the end of the day, makes it available to people. And not even end of day, right? So whenever we're talking about the storage bit here, we're talking about, anything sort of that isn't super latency sensitive. So, might be a second delayed or whatever type thing. So including the real-time databases in these. And we come in and we take a look, and a lot of the time, this is kind of a common ask at the moment. People are doing cloud migrations, for example. How can I move my infrastructure to the cloud? And again, there's a hybrid approach that we've adopted in a number of places, which is essentially to kind of say, okay, well, let's separate the 2. You've got the real-time bit, which probably still lives on-prem, maybe in colo, whatever. It's got all the fancy magic. And then you've got the storage bit, right? And the thing is that this bit here is very standard. These are standard problems. Everybody has to solve them, and there shouldn't be 48 million different implementations of the same thing, right? There's no real value add to the business here, right? How you kind of get data, you store it reliably, and you make it available to people. The bit on the left is where all the business value add is. So, so we've been working with KX on this, and we've been talking to them about their new software, so the microservices piece. and also FinSpace. So we've been working with them in these two. And we really like the approach, right? We sort of say, well, yeah, exactly, right? Solve the problems, solve them once, solve them in a standard way. Everybody does the same thing. It'll make everybody's life easier. More people can focus over in this end of this part on the left-hand side, and get more money for whatever it is, or improve the business essentially. And the way we went about that, we've been working with them, learning about the technology, doing little implementations and things like that. We decided to sort of, for us to learn about it, set them a number of challenges, right? Put down some standard problems and sort of get them to show us that they were solved or no longer problems that had to be solved by everybody. So, and they sort of said, yeah, all these things you've said, they work. But I don't think you should take my word for it, right? So what I'd like to do is get Connor to come up here, and I'm going to show you the things that we've talked about, and you're going to tell me and everybody else how they're solved. And apparently that mic works.
That's it. Where do we start? Here?
Where do you, well, here. I think we'd be about the same. If that's all right then. Yeah. You're taller than you look on Zoom. So Connor and I used to work together. Like I said, I worked for First Derivatives for 9 years. Very much enjoyed the whole time I worked there. Worked on a project with Connor, and then I left. So, yeah. Right. So we're talking about. Let's get into it, right? So we're talking about again. Microservices, right? So again, leading on from the AWS presentation earlier, microservices and FinSpace, which is built on top of the microservices, right? So I want you to tell us how some of these standard problems nobody has to build around anymore, right? So we're going to talk through the problems, and then I'll sort of say how we've done them in the past, and you can tell us how much easier it's going to be, okay?
Sounds good.
Right, excellent.
The answer is FinSpace. To pretty much all of them.
Okay, right, that's good, right? We're on brand then, right? Okay, right, so let's get into some of the details, right? So storage tiering, this is a problem we've solved in a number of places. Different, you've got different access patterns. Storage devices cost different amounts of money with different performance characteristics. You can put data on fast, slow, medium, whatever. So, and even this thing on the right-hand side that's meant to be a bucket. So that's a object storage bucket, right? If you like my diagram skills. So how do we solve these? So in the past, for object storage, you have to stick a POSIX compliant layer in the middle. You got KDB, you got a POSIX compliant layer in the middle to talk to the object storage, and then you got to build batch jobs because the problem with storage tiering is it's not setting it up. It's kind of moving the data around and making sure that once it's moved, it's in the right place, it's still accessible, and there's a lot of what turns out to be shell scripting to make this all happen. So can you explain how this works now?
So for object storage, we've integrated natively, so no more requirement for things like Fuse and Objective-FS. So that abstraction layer is no longer required. On the batch move of data, the storage manager, which I think some of you will be familiar with, it takes care of all of the migration between the tiers. So from block storage to object storage, from IDB, RDB, HDB, that's taken care of atomically whilst leaving the data online. And then on the FinSpace side, the approach is kind of to actually start in the cold tier and hydrate into the faster tiers. So everything's backed up by S3. Essentially, it's your golden source. Yes.
So problem solved?
Yes.
Yes. All right. Cool. Right. Okay. So the next I think I'll do the next couple together, right? Again, standard KDB tick style architecture. People who have done stuff with KDB tick will probably be familiar with this problem. You know, you've got market data, you've got a trigger for end of day. There's always a bit of market data that arrives in the wrong day. So, you know, something that's timestamped just before midnight arrives just after midnight, assuming your trigger's at midnight. Gets stored down and gets stored down into what is technically, depending on how you want to timestamp it, the wrong partition. So again, how we would solve this in the past, you know, you can send the trigger from upstream, so take it out of the ticker plant, or send the trigger from downstream. Both are kind of fragile because how long do you wait? That's kind of a problem. Or you can try and fix it in the data access layer. So instead of just stick it where it goes in, put a data access layer around it, data API, fix it on the way out. But that kind of brings performance issues at times, right? Depending on what it is you're trying to do. So that's number one.
2 parts.
2 parts. Number 2, really late data. So, you know, it could be like a T+1 load from a back office system. Or we did one with trucks that drive around the Australian desert and used to be out of range of Wi-Fi signals or phone signals or phone masks or whatever, would drive around for like 5 days and pull in and upload 5 days worth of data to the sensors database. And you go, right, okay, now I got to sort all this data out. So, you know, again, that's slightly, in my mind, that's a slightly different problem, but it's still late data. So basically, you know, in those cases, you would, again, you could fix it in the way out in the data access layer, or you would upsert it to the correct partition, resort the data, repartition it and all, or reattribute it and all those kinds of things. So is this a fin space solved problem?
So this is again taken care of in Storage Manager. The first slide was slightly late data. So that actually can be configured. So when your end of day writes down, you have like a snap time. So you can say, instead of doing end of day at midnight, you can say do end of day at 6 a.m. But the late data is held in an IDB. So yeah, you don't have to handle it at the data access layer or the ingest layer. It's kind of handled in both because the data is still always online as well. For very late data, it's the same concept. You're using the IDB. And then based on whatever the partition column is, it will save it to that date casted partition on disk. Yeah.
So done?
Done. Yeah.
Nice. Okay, all right. High availability, right? We're all familiar high availability challenges. Slightly more boring diagram here. It's running out of time. Ultimately, the challenge is you want to ensure reliable capture and availability of data. A lot of the times, the solution's a hot infrastructure, so you end up storing everything twice. You know, twice the compute, twice the storage, all those kinds of things. So, is there anything that makes this cheaper or easier?
This one, so there's a new service, a new component from KX called RT, and on the high availability side, it is a Raft consensus module. So what that will do is essentially ensure determinism across your stream and real-time data. So you can have hot RDBs and actually do hot query. And then I guess on the cost side, double the infrastructure, that's no longer the case because we're using like the same storage. So you're not having a replica of your HTTP, so you're bringing down costs that way. But yeah, it's still kind of hot on the intraday side because you need like multiple nodes to ensure consensus. So yeah, that's a microservice.
Okay, but the consistency problem is...
Yeah.
Okay.
Yeah, that's in there.
Okay. If anybody else wants to ask Connor some questions as well, that's fine too. Okay, so here's what we come up with, right? Research sandbox usage, right? You've got different usage profiles within an application, within a KDB environment a lot of the time, right? So you've got applications that use the database, They're usually predictable access patterns, certain times of the day, all very well constrained, et cetera, et cetera, et cetera. And then you've got quant users who just want to do whatever crazy stuff the quants want to do. So they've got very unpredictable access patterns, can write things that are just wrong. And what you got to try and do, again, we've put this in these kinds of solutions in a couple of places. You can obviously segregate processes, so you've got different KDB plus processes that those users access, so they're segregated at that level. But a lot of the time, there's resource contention underneath, right? So there's things that you can again isolate a little bit, but a lot of the time we'll be hitting the same storage devices and storage mediums. Some places just replicate their whole data set for quants. Is there FinSpace help here?
Yeah, this is the whole value proposition of FinSpace. So just unleashing data science use cases. One copy of the data, spinning up compute around that, turn it off, keeping costs under control, not having to replicate the data. I think even Kartik is going to speak about this, what they're doing at Goldman.
So I've stolen his thunder?
This is, I think, their topic.
Yes.
Yeah. Yeah.
Okay, cool, brilliant.
Very good.
Okay, so usage spikes, again, sort of similar-ish problem, but slightly different, I think. I think Tim kind of touched on some of this stuff earlier. So again, we've built systems like this and tied them in with Kubernetes, in a couple of different places. So, a KDB system, you've got different access patterns during the day. So for example, you might have algos at prime pre-market open, that causes a spike in usage in your KDB environment. You might have market close reporting that needs done that causes a bit of a spike. So you can either size the thing for the spikes, for the query spikes, but ideally what you want to do is scale the system up and then scale it back down again for cost-saving measures. How are we on this one?
Yeah, again, FinSpace, auto-scaling.
So done? Well, Tim's already said it,
Tim
so
can vouch.
Yeah. Okay, so again, an area that we've built and seen lots of different versions of this kind of thing. So a data access layer, as what Alex was just talking about, very, very important in a large-scale KDB environment. Although we've seen a lot of places that don't have them. They've got huge setups and they don't have one of these, and it's concerning. So the challenge is obviously all the data doesn't live in the same place. You've got data spread across processes. You've got different, might be by asset class or whatever it might be. It might be sharded by time, for example. And you need a proper data access layer to allow the users to get access to all that data, or data API. And it's hard. It's hard because you got data in lots of different places. So it needs to be able to locate data, handle duplicates, aggregate, and even maybe do joins. How's that?
It's multiple microservices. It's a combination of the data access processes, which are effectively RDBs, IDB, HDBs, as well as a service gateway. So what you're doing there is you're actually labeling data sets for discovery. So then they're cataloged and they roll up into the service gateway. So then when a user comes in, they never have to know where data is. They never have to know this region is at this process, this asset class is at this process. It could even be a sensitive data set where they maybe don't have entitlements. So the service gateway just abstracts that completely. And it does support joins. So
even as of joins?
Yes, maybe not for IDB. I need to check that. But yeah, it supports as of joins.
He said it. All right, cool. So the last one, right? volume spikes. So again, right, this is a very difficult one. Market volatility causes large spikes in volume, leads to system instability. Again, we haven't actually built this, but we have theorized over it. We've prototyped it, but we didn't actually build it. So if you wanted to fix it, you could just size for the worst case, but that's very expensive. So the idea we were thinking was, you write data down to disk very as quickly as you can to an intraday set, and then you've got a rolling window of multiple in-memory processes, each which take a different time slice. So obviously you can't keep right up to date streaming to disk, but if you have the in-memory components, you can use them to serve the latest data. The idea being that once data reaches a certain age, it goes out of memory, and then you get a new, the process kind of takes the next window. The idea being that if you had a volume spike, the time window that's in memory reduces. So you've got the same amount of data in memory. It just covers a smaller time window, and as long as you've got enough overlap with your intraday, then you should be okay. So is this a fin-space solution?
This is a hard one. So this again, on the storage manager side, it's a combination of like what you have done before, which is like a smaller RDB, rolling logs more aggressively, spinning up more processes. So as you have ever increasing data volumes, that's covered. And then I guess the burst use case as well, where you just have a really large period, that's also covered. But I think this one is to the complement of AWS. This is something that they will definitely address, because this is like the primary use case that they're hearing from customers. I have this problem, fix it. So I would definitely say FinSpace, keep your ears to the ground on what they're going to do in this space.
Okay, cool.
So
Thanks.
maybe not a yes today for
yes
all
in the
cases,
future,
but yes in the future.
Okay, cool. Thanks, Connor.
Very good.
Right, last slide. Finish up. Out of time. So takeaways that we'd like you to take away with you. Yeah, one of the things we've seen, if you're doing a cloud migration or a re-engineering, even a re-engineering piece, don't just copy and paste. Optimize your capture and storage. Take advantage of new technologies available. KX technology landscape, like I said, we think the stuff that's happening, especially with FinSpace, is going to be great for a lot of customers in terms of taking that problem away and allowing them to focus on something more, to improve their business. And also, we are now called Data Intellect, not AquaQ. If you hear any of us say AquaQ, then you get a $5. If you hear Steve Turner say it, you get 20. So, yeah, come and chat to us if you'd like us to have a look at anything for you. And Gary has maturity matrix for KDB tech and for KDB architectures, and he absolutely loves talking about that. So it'll tell you everything that's wrong. So go and talk to Gary. Okay, cool. Thanks.